A range test is a test, or a number of tests together, performed to determine a receiver's ability to decode transmitters at various distances and in varying conditions at your chosen research site. This can be done in a number of ways, but a simple method is to use a range test tag with a fixed time delay at a fixed location, and a number of receivers at fixed locations that are known distances from the tag. Acoustic signals are affected by water quality, weather conditions, noise, both biological and man-made, mooring design, and the bottom type and geomorphology of the area. All or some of these acoustic influences can show themselves during range testing, making you better informed when analyzing your data. Water quality at the research site can have a large impact on the acoustic properties of the area and can add variability to these acoustic properties. Factors such as salinity, turbidity, and temperature can affect acoustic signal absorption and refraction. A negative change in weather conditions usually reduces an acoustic signal's ability to be detected. The distances the signal can reach during calm weather cannot be reached during adverse weather because of the additional noise caused by the weather. For example, this graph shows the detection rate by percentage of a V16 stationed 500 meters away from a receiver moored close to the water surface. The graph shows a significant drop in detections occurred at approximately the same time each day. But why? Wind speed data collected at a nearby weather station shows an increase in wind speeds during the same hours. The detection disruption was caused by an increase in wave noise. Noise, whether its source is man-made or biological, causes an additional challenge for acoustic signals to be decoded by the receivers. For a receiver to detect an acoustic signal, there must be a large enough difference between the noise level and the strength of the signal. This is referred to as the signal-to-noise ratio. If the signal-to-noise ratio is too small, the signal is lost in the noise and the tag isn't detected. What can improve the signal-to-noise ratio? Either the signal needs to be stronger by being more powerful or closer to the receiver, or the noise needs to be less. Here's an example of a noise and detection problem. These are the noise levels measured near a group of snapping shrimp. When the snapping shrimp were active, the noise levels were much higher than when the shrimp were non-active. This increase in noise made it more difficult for the receiver to detect the test tag, and the detection rate dropped dramatically during the shrimp's active periods, as indicated with these areas of yellow. When the receiver was moved away from the active shrimp, the detection levels increased. How a receiver is moored can affect how well the acoustic signals are received. There are a number of ways mooring can be accomplished, but keep in mind that the hydrophone on the receiver works best when it is unobstructed. In other words, the hydrophone should have a clear line of sight to the tag. Moorings can cause a shadow area where it is more difficult to detect tags. This happens when part of the mooring blocks the receiver's line of sight to an area, like the float does in this example. There are times when shadow areas can't be avoided, but often they can be kept to a minimum. For example, if the float and receiver were farther apart, like this, then the shadowed area is much smaller. Other mooring considerations to keep in mind are not to have any hanging or loose material near the receiver that could bang against the receiver or something in the area and therefore increase the noise level. And be sure that there are no mechanical coverings around the head of the receiver, like neoprene, that could impede the acoustic signals. Now let's take a look around the research site. We know that receivers should have a clear line of sight to the tags, and we've seen how moorings can create shadow areas. The area's geomorphology and the vegetation can also create shadow areas. If vegetation is between the tag and the receiver, and it's dense enough, it can hamper the acoustic signals. The best way to determine if vegetation is going to be a problem is to perform a range test above the vegetation and again in the vegetation and compare the results. Geomorphic conditions in the area, whether natural or man-made, can also block the acoustic signals. Another aspect of the environment that can affect acoustic signals is the bottom type. A graph of the signal-to-noise ratio at different distances and depths in an area with a sandy bottom looks like this, where the darker the blue, the larger the signal-to-noise ratio. The teal color indicates the ratio is very low and the signal is lost in the noise. The same experiment in an area with a rocky bottom gives us data that looks rather scattered and has a different underlying shape. If we compare the two graphs, it's easy to see that the two bottom surface types cause very different acoustic results. We know that different bottom types will affect acoustics differently. When should you perform a range test? Begin after you deploy your receivers, but before you begin your study. This helps you become familiar with the acoustic properties of the area and of your moorings, or in other words, to become familiar with all the things we've already discussed. But don't rush out and buy your tags yet. We suggest you use a range test tag during the range test. These tags are designed to be attached to a line and transmit at a fixed interval for easier data analysis. We can help you select the best size, power level, and transmitting interval for your test tag. Ideally, you should also perform periodic range tests throughout your study, especially if your study area has wide swings in acoustic conditions. For example, a change in thermoclines caused by a change of season can have a temporary effect on the acoustic properties in an area. Also, if you move your receivers to a new area, even if the distance is not great, be sure to perform another range test. We've seen large differences in the acoustic properties of two areas that are only a kilometer apart. Why does all this testing matter? Well, let's use a gate as an example. Let's say you have a river that you want to monitor, so you do a brief range test and determine that your receiver consistently detects tags at a certain distance. So you set up your gate with the receiver spaced according to your brief range test. Maybe on the day you did your range test, conditions in the river were acoustically favorable, and your gate is rather robust. As we know, conditions never remain favorable forever, and at some point the receiver's acoustic range decreases. Now the receivers can't detect at the same distance that they could during the ideal conditions, and your gate is not as robust as desired. Performing range tests for long periods, especially allowing the test to cover a variety of acoustic conditions, gives a better picture of how well the receivers will perform during a variety of conditions and allows you to design a better gate. So remember to always make range testing an important part of your study. Range test data arms you with a better understanding of the differences between the performance of the equipment due to the factors discussed and the biological performance of the tagged creatures. Feel free to contact Vemco for assistance when planning your range test.